Okay, here is a problem where we have a swing, and the swing is 0.5 meters, and the weight of the mass at the end of the swing is 550 newtons. Now, the swing is pulled back such that it is, the center of gravity of it is approximately 3 meters above its original position. And what we're going to find out is how fast is the swing going when it gets back down to the bottom. So, in order to figure this out, we have to kind of compare energies here. We have to say, alright, the initial energy is equal to the final energy. So, at this point, this is the original position, okay, and this is the final position. If this is the initial position, what type of energy do we have in this situation here? Well, originally we have gravitational potential energy, and finally, when it's at the bottom, at this location here, we have kinetic energy. So therefore, let's scroll this down a little bit here. So therefore, initially we have mgh, and finally we have 1/2 mv squared. Now the m's, it's the same mass, so we can cancel out the m's. We're trying to figure out how fast it's going at the bottom, so we're solving for v. Therefore, we can rearrange the equation to be 2gh equals v squared, and therefore root 2gh equals v. Now that is going to equal the square root of 2 times 9.8 meters per second squared times a height. Now the height here is not 0.5 rather, because it wasn't 0.5, it was 0.3. That's the height by which it fell here. So we can do that here. And when we multiply that through, what do we get? Someone have a calculator? Yeah, correct. The answer is 2.42 meters per second. Now, the next question is, what if the mass falls or swings down, but instead of it being at 2.42 meters per second, what if it's only swinging, what if it only reaches the bottom of the swing, say at 1.5 meters per second? So what if, this is part B, final bottom velocity is only 1.5 meters per second. Question: how much energy was lost to friction? Okay. Well, in order to do this, we're going to have to figure out the change in energy at that point. So we have 2.4 from part A. However, our actual velocity is equal to 1.5. So what's the actual difference? Well, the difference in energy is going to be delta is going, and they're both going to be kinetic, right? So 1/2 mv a squared minus 1/2 mvb squared. The problem, we have both velocities. The problem is we don't have the mass, and we can't cancel the mass in this situation either. Fortunately, though, in the original problem, we were given the force of gravity, and that was 550 newtons here. So let's go with that, and the 550 newtons, if the force of gravity, which is equal to mg, is equal to 550, that means that m is going to equal 550 newtons divided by g, and that's going to equal 550 9.8 divided by, which is 56, approximately 56 kilos. Okay, so now we can work out the change in energy. And that's just going to be, and we can actually simplify it too slightly. We can go 1/2, oops, let me start again. 1/2 times, we can factor out the 1/2 in the m and go VA squared minus VB squared, and that's going to be 1/2 times 56 kilos times VA, which was 2.42, I believe. Wasn't it a 2? Yeah, 2.42 squared minus 1.5 squared, and this is going to be 2.42, enter, or actually just squared, 1.5 squared minus 56 times 0.5 times, and it gives us 100. 0.9, well, basically 100 point, or approximately 101 joules. And so that's how much energy was lost to friction. Okay, that's the end of the problem.